Now let's look at 2016 AP Physics 1 career expense question. Number 1. You have a wheel of mass m, remains spoke, and rolls down the ramp with angle theta. It's a typical rolling down the ramp question. You have a static friction, meaning it's not slipping, as it says right there. So you have to use static friction. Right, and on the diagram below, draw and label the forces that acts on the wheel as it rolls down the ramp. Indicate at which point the wheel each force is exerted. Draw each force as a distinct arrow starting on and pointing away from the point at which the force is exerted. Okay, and lengths of arrow need not indicate relative magnitude. Okay, that's a good point. Usually you have to match the relative length, but not in this question. All right, obviously you have gravity. Gravity starts from center of mass, should be here. So you have gravity, I'll say mg, large mg. Then you have normal force. Remember, normal means perpendicular to surface in physics, right? In math, normal means something like this. Let's say this is a graph, then you have tangent line. So tangent, that's the tangent line. Normal line in math, that will be this line. So normal in math, it's perpendicular to tangent line, but normal in physics is perpendicular to the surface. Since that's the surface, normal force should go from here, pass through the center of mass, and that will be normal force, right? And usually this is mg cosine theta, right? That's the portion of the gravity. And you have frictional force going to, right? So force of friction. All right, and as the wheel rolls down the ramp, which force causes a change in angular velocity, which is omega, right? With respect to center of mass. Well, angular velocity change because of torque, right? So when you have, and torque is R cross F. So when you generate torque, in this case, this will be friction, and that will be just radius. Basically, this is the force, and this is the all vector actually to generate the torque. And this makes, remember, F equals ma, torque is I alpha. So this I is I of the wheel, which consists of circular piece and 3 spokes. Sometimes they ask you like what is I consist of, but you can say there is a rim. Usually this rim outside is mr square, and this spokes is like a rotating something like that, right? So that will be probably 1/3 ml square. But once again, this question they didn't really ask you this, but for the future reference, I'm just giving you this. So basically, there is a frictional force which generates torque, and that will generate alpha. Okay, so in this case, you have to say which force. So you have to say force of friction. And what's the reasoning? Force of friction creates torque, and because of that torque, it creates angular acceleration. Because of this angular acceleration, your angular speed or angular velocity will change. Okay, you can elaborate now. For this ramp, the force of friction exerted the wheel is less than maximum possible static force. That's actually important. This is a little tricky to understand because force of friction, usually you write equals mu Fn, normal force. But there are 2 different cases. If you have static friction, that's mu S Fn, but there is less than or equal sign. You have to be careful with this. If I give an example, let's say you have a mass of 10 kilogram, and let's say mu s is 0.5, and if you apply force of 20 Newton, what is acceleration, what is the force of friction, right? So let's say let's think about this. So right now you have gravity, which is mg, it's 10 kilograms, so that'll be 100 Newton. There'll be normal force of 100 Newton. But based on this equation, your force of friction static is 100 times, that's the normal force. Mu s I give you as 0.5, which is 50 Newton. This doesn't mean you have 50 Newton force backward, because if this is true, the block will accelerate backward, which is nonsense, because I apply 20 Newton forward and all of a sudden this block goes backward with force of 50 Newton, so it'll accelerate backward probably 3 meters per second square. That can't be true. So this value is theoretical maximum static friction. Okay, so the real answer, if I ask you what is acceleration and what is force of friction, acceleration will be 0 because it's not gonna move, and because we know acceleration is 0, that means F net has to be 0. But remember, there's a force applied 20 Newton forward, so there must be force backward 20 Newton. So the correct answer for this type of question, what is force of friction, you can't really use mu SFN. You just use this data to check if it's gonna move or not. If it does not move, you know F net equals 0. So force of friction is actually whatever you applied. So that's what this line means, okay? That's why it says static friction exerted only 40%. Right, now if I draw this, let's look at force diagram on this. So you have, oops, I think the ramp was the other side, right? The ramp was in this direction. So right now you have mg, and you can break it into two components. One is going in that direction, one is going in that direction, and this angle equals that angle. So you know you've done this many times. So this portion gravity that's pulling down is mg sine theta, and this force pushing it in will be mg cosine theta, and that will be the normal force upward, right? So normal force this direction will be mg cosine theta. Then you have force of friction, which is mu mg cosine theta. But in this case, static friction, you can't say this force of friction is mu s mg cos theta, because this actually we don't know. Okay? Because if it's not sliding, because you're using static friction, this value will be, force of friction will be actually less than mu s mg cos theta. So in this question, they told you this is actually 40% of the component direct opposite side of friction, which is 40% of this, right? So in this case, F net will be mg sine theta minus 40% of mg sine theta, which equals ma. It's basically 1 minus 0.4, so you get 0.6 mg sine theta equals ma. So acceleration will be 0.6 g sine theta, right? So here, derive expression for linear acceleration. So a is 0.6 g sine theta. Okay. Now let's actually move on further on how you relate this into angular speed. Okay. So let's think about this. What are the torque on this? So the only torque can be generated is actually force of friction. I don't know what it is, but in the question it says 0.4 mg sine theta, right? But I'll just leave it as force of friction. So torque net equals force of friction times radius of this equals I alpha, right? So then from here, from using this, if I know what I is, usually it has format of some constant mr square is the I. So if you put it in, and you can cancel this. Then if you divide I on the left side, you can figure alpha is force of friction R over I. And if you know the value of I, if you put that in, actually this comes out nice equation, okay? It will be cancelled most of them out. And also the relation is alpha, if you know, if you find this, if you multiply by R, this has to be A that we calculated above, right? This was like 0.6 sine theta. This has to be A. That is the condition for rolling without slipping, okay? So that's, because sometimes they actually deal with this. That's why I'm explaining this, all right? Move on. Now, second experiment, same ramp, a block of ice with mass m released from the rest at the same instant. The wheel is released from the rest. Blah blah blah. The block slides down, and negative friction. So there's no friction. Okay, in which of the which is bottom ramp greater speed. All right. So I'll say the block, and you can reason this in two different ways. You can reason it as a force. Also, you can reason it as energy. Okay? So remember, if you look at the force, before going here was mg sine theta. That's the part of gravity. And you have force of friction. So Fa net was this mg sine theta subtract force of friction divided by the mass. That was what A is. But right now, the only force you have is portion of gravity, which is mg sine theta, which is ma. So right now, acceleration of the ice block is actually g sine theta. Okay. Before it was g sine theta subtract force of mg sine theta subtract force of friction divided by mass. Right now, your acceleration is actually bigger because there's no force backward. Okay, so you can explain something like that. Explain in terms of energy. Okay, so before this rolls down, and you have h. So right now your potential energy of gravitational potential mgh. Now this will turn into two types of kinetic energy. So one is translation kinetic energy, which is 1/2 mv square, and the other one is rotational kinetic energy. Right? So this will go into translational, which is moving this one, the center of mass going forward, going down the ramp, plus kinetic energy of rotation, which is 1/2 I omega square. So you have this total energy, which is basically gravitational potential, will be separated into translational and rotational. But in the case of ice cube, mgh becomes just 1/2 mv square. Because you don't have this, that means you can use the full gravitational potential energy into the translational kinetic energy. So this v has to be bigger compared to that v, okay? Because this v is shared on two of them. In fact, there's a relation between this v and this omega in the case of rolling without slipping, because we know L omega is v. That was one of the bridge equation. So you can replace either v by L omega or omega by v over r. Then you can actually figure out what percentage of this potential energy goes into translational or rotational. Okay, I think I mentioned that in my lecture earlier, so I want you to note that. Okay, so that's what it is. So in terms of energy, you have gravitational potential into kinetic, translational kinetic, or rotational kinetic. Since you separated, this velocity will be smaller compared to when total gravitational energy goes into kinetic energy, translational kinetic energy. Okay, so that's the way you explain in terms of energy, right? All right, that was number 1.